Wi-Fi 0, 802.11. The first version of Wi-Fi appeared in 1997 under the IEEE 802.11 standard. Back in the late 90s, something revolutionary happened. Engineers managed to transmit data through the air at 2 megabits per second using a frequency of 2.4 gigahertz. This wasn't fast by today's standards, not even close, but imagine the breakthrough. No more cables snaking across your desk, no more being tethered to one spot. Computers could finally talk to each other wirelessly. Of course, the technology had serious limitations. Range? Minimal. Speed? Barely enough for basic file transfers. Streaming video? Forget about it. But here's what mattered. Wi-Fi 0 proved the concept worked. It showed that wireless data transmission wasn't just science fiction anymore. Fast forward to 1999. Wi-Fi 1, or 802.11b if you want to get technical, changed everything. Speed jumped to 11 megabits per second, still using that same 2.4 gigahertz frequency. This was the version that finally made wireless internet practical for everyday use. Homes started getting wireless routers, schools installed access points, small businesses went cable-free. There was just one problem: interference. Your microwave interferes with Wi-Fi. Bluetooth devices, same frequency band, same interference issues. Cordless phones, you guessed it. But despite these headaches, Wi-Fi 1 brought wireless networking to the masses. It democratized internet connectivity in a way cables never could. Here's where things get interesting. Also, in 1999, 802.11a launched, what we now call Wi-Fi 2. Instead of competing for space on the crowded 2.4 gigahertz band, it pioneered the use of 5 gigahertz frequencies. The results were impressive: 54 megabits per second, nearly 5 times faster than Wi-Fi 1, and with far less interference since the 5 gigahertz band was basically empty. But there's always a but, right? Physics became the enemy. Higher frequencies means shorter wavelengths. Shorter wavelengths struggle to penetrate walls and obstacles. So, while Wi-Fi 2 was faster and more reliable, its range was disappointing. This is why you saw it mostly in corporate environments where they could install multiple access points. For home users, it wasn't worth the trade-off. 2003 brought us 802.11g, and this time the engineers got it right. Wi-Fi 3 took the best of both worlds. It went back to 2.4 gigahertz for better range and wall penetration, but it matched Wi-Fi 2's speed of 54 megabits per second. Even better, it was backward compatible with those older Wi-Fi 1 devices everyone still had. This became the sweet spot. Affordable routers, good speeds, decent range, and compatibility with older tech. By the mid-2000s, Wi-Fi 3 was everywhere. People started actually using wireless for meaningful tasks, downloading music, browsing the web without lag, even sharing files between computers. Early smartphones began appearing with Wi-Fi capability. The wireless revolution was truly underway. 2009, Wi-Fi 4, 802.11n. This wasn't just an incremental upgrade. This was a fundamental reimagining of how wireless networking should work. First innovation, dual band operation. No more choosing between 2.4 or 5 gigahertz. Use both simultaneously. Older devices could stick to 2.4, while newer gear could leverage the cleaner 5 gigahertz band. Second innovation, MIMO. Multiple input, multiple output. Think of it like this. Instead of one antenna talking and one listening, you've got multiple antennas working together. Some transmitting, some receiving, all coordinated to maximize throughput and minimize interference. The result? Speeds up to 600 megabits per second. That's nearly 10 times faster than Wi-Fi 3. Suddenly, HD video streaming actually worked reliably. Online gaming became smooth. Large file transfers were, well, not instant, but tolerable. Wi-Fi 4 dominated for almost a decade because it finally delivered the performance people needed. 2013 arrived with 802.11 AC, Wi-Fi 5. The strategy here was simple: abandon 2.4 GHz entirely, Go all in on 5 GHz, maximize speed and stability. Theoretical maximum 6.9 gigabits per second. In real-world conditions, you'd never hit that, but even a fraction of it was blazingly fast. The real innovation was MU-MIMO, multi-user MIMO. Previous versions could handle multiple devices, but they took turns. MU-MIMO changed that. Your laptop downloading a file, your phone streaming music, your tablet on a video call, all happening simultaneously, all sharing bandwidth efficiently. This generation defined the modern smartphone era. Between 2015 and 2020, basically everything came with Wi-Fi 5, laptops, phones, smart TVs, tablets, even refrigerators. It was fast enough, reliable enough, and everywhere. By 2020, we faced a new problem: device overload. Wi-Fi 6 or 802.11ax wasn't just about raw speed, it was about efficiency, about handling dozens of devices without everything grinding to a halt. Enter OFDMA, orthogonal frequency division multiple access. Here's what that means in English. Instead of giving each device the entire channel for their brief moment of transmission, OFDMA divides channels into smaller subchannels. Multiple devices can transmit simultaneously on different subchannels. It's like switching from a single checkout line to multiple express lanes. Wi-Fi 6 also introduced target wake time. This lets devices schedule when they'll wake up to transmit or receive data, rather than constantly staying alert. Result: massive battery savings for smartphones and IoT devices. Top speed: 9.6 gigabits per second. But the real win was performance in crowded environments. Apartment buildings, offices, airports, stadiums, places where hundreds of devices fight for bandwidth. 2021 gave us Wi-Fi 6E. Same technology as Wi-Fi 6, but with access to an entirely new playground, the 6 GHz frequency band. Think about this. The 2.4 and 5 GHz bands are packed. They're like crowded highways during rush hour. The 6 GHz band? It's a brand new, empty superhighway with wider lanes. More bandwidth, less interference, lower latency. This matters for demanding applications: 4K and 8K video streaming, virtual reality, high-end gaming, large-scale video conferences. Wi-Fi 6E isn't about faster top speeds, it's about maintaining high speeds even when conditions are terrible. And now we arrive at 802.11be, Wi-Fi 7. This is bleeding-edge technology. We're talking about 46 gigabits per second, theoretical maximum. Key innovations: 4K QAM, which packs more data into each transmission, and multi-link operation, where a single device can transmit and receive across multiple frequency bands at the same time. Imagine your phone using 2.4, 5, and 6 GHz bands simultaneously, aggregating all that bandwidth. What does this enable? Cloud gaming with zero perceivable latency, multiple 8K video streams in one household, virtual and augmented reality that actually feels real, smart homes with hundreds of connected devices running seamlessly. Wi-Fi 7 isn't just faster, it's redefining what's possible with wireless networking. So there you have it. From 2 megabits per second in 1997 to 46 gigabits per second today. Each generation built on the last, solving new problems, enabling new possibilities. Now I'm curious, which generation are you using right now? Drop it in the comments. And if you want to understand internet speeds even better, check out my other video. I'll link it below. Don't forget to subscribe for more tech breakdowns like this one.